Alright, let's rock these last two problems. Find the indicated roots on both of them. Write the answer in trigonometric form on this first one and in standard form on the second one. There is a formula that we use for this where we do the nth root of r times cosine. Maybe I'll just look and make sure that I write it down right. 2 seconds. Cosine of theta plus 2 pi k over n plus I sine theta plus 2 pi k over n in parentheses. So we got to figure out what these are. The fifth roots, that tells us that n is 5. K then has to be the numbers from 0 to 1 less than 5. 0, 1, 2, 3, 4. You should end up with 5 numbers here, not a sixth. You shouldn't have a sixth number, which would make this have a 5 at the end. We have r, we have theta, we are ready to plug in. So just in general, what we have is the fifth root of 6 cosine pi over 3 plus 2 pi k over n, which is 5. Now, when I write the second one, I'm actually going to simplify, or start to simplify. I want to get a common denominator on top here. Instead of this 2, I'm going to make it a 6, so that this is over 3. That gives me pi plus 6 pi k on top over 3, but it's over 3 and over 5, which means it's really over 15. And if you need to work that out in a more step-by-step fashion, then please do. Now we're going to start plugging in our values for k. When k is 0, we get the fifth root of 6 cosine. We put in a 0 here and get pi over 15 plus I sine pi over 15. We plug in k equals 1, so that's the fifth root of 6 cosine. If I put in a 1, I have pi plus 6 pi, which is 7 pi over 15, plus I sine 7 pi over 15. K equals 2. The fifth root of 6 cosine, so that's pi plus 12 pi, which is 13 pi. Also remember that at this point we can start looking at our pattern. It's 6 from pi to 7 pi, 6 from 7 pi to 13 pi. So each of these is 6 apart, and that happens to have to do with that number right there. So 13 pi over 15. And then k equals 3 gives us the fifth root of 6 cosine. If I add 6 to this, I get 19 pi over 15. And k equals 4. Fifth root of 6 cosine, add 6 more to this and get 25 pi over 15, which we can simplify to be 5 pi over 3. Okay, 30. We've got cube roots of unity, and so remember, unity is talking about the number 1, which in standard form for a complex number is 1 plus 0i. So we're basically doing what we did here on 29, but we do have to know that extra information there. We're finding the cube root, so that's only 3. Our k will be 0, 1, and 2. Plug into our formula and get the third root of 1. Oh, well, I guess we need to put this in trig form, don't we? 1 plus 0i is this point out here, has a radius of 1 and an angle of 0, either in degrees or radians, whichever you choose to use. So, cube root of 1 cosine theta, which is 0, plus 2 pi k over n, which is 3, plus, we can simplify that a little bit by just making it 2 pi k over 3. And then we want to do k equals 0. So the cube root of 1 is 1. We don't need really to keep writing that. This is cosine. If we plug in 0, we get 0 plus I sine 0. We'll do standard form here in a sec. K equals 1 will be cosine of 2 pi over 3 plus I sine 2 pi over 3. And k equals 2 is cosine 4 pi over 3 plus I sine 4 pi over 3. We want these to be in standard form, and we're going to use the unit circle to help us. Cosine of 0 is 1. This is 1 plus 0i, which that's really just what we started with, right? So that would be pretty easy. Cosine of 2 pi over 3 is negative 1/2. Sine of 2 pi over 3 is square root of 3 over 2. And cosine of 4 pi over 3 is negative 1/2. I sine 4 pi over 3 is negative square root of 3 over 2i. So that right there is our answers to that.